Hi guys, today we discuss flyback topology. So how it is working, and we can discuss. So each and every viewers, please click on our uh, click on our yes, subscribers and give me commands, valuable commands. We can update you next section, and you can subscribe our listen. Then only you can get for each and every videos. What are the videos we are uploading, you will get it, you can see. So coming to today, we can discuss playback topology. So how it is working for playback topology, we can explain you this section. So this is for basic structure of playback topology. So here we are using for one switch, one pulse transformer, then you're using for diode and capacitor and load. Here we're using for DC input plus and minus. So how it is working, you know that. See how it is working, I can explain you. See, and this buck converter major playback topology, and some other topology will be there, buck boost and boost topology. So what is the major difference between means? This will be isolated primary section. This is a primary section, this is a secondary section. So isolated the voltage, this is for fully for high voltage, this is for fully low voltage. So like that isolation will be there. So due to only we are called for playback topology. So another topology, buck boost and all, we don't isolation will be there, not there. So there is a major difference, and we can use for playback topology multiple outputs. So buck boost we can't use for that multiple output. There is a major difference. And here will be switch will be there. This is for pulse transformer, and this is a diode, this is a capacitor, this is a load. So I'm applying the plus and minus voltage. This is a switch we can switch. I'm example telling, we can use for here a MOSFET, a transistor, like that. So switching the pulse transformer. So this for like that two symbol will be there. So now it's on condition. How it is on condition, how will be there means, so on condition uh, only this primary section only should be working, and after that this section only will work, will be there on condition. And off condition, this off condition, uh, this entire thing is working, and this is off condition totally. So like that this first transform is working. And I'll show you some this one dropped also. We'll see the how it is working, and those things, right my point. So now is the off state. How we called off state means, I think the switch will be the switch is there, no, this part not connected. So this off state, it should be connected means now is the on state. So on state, how it is working means, only for this will be their power, and it will flow, power will be flow for this to this, like that will flow. And next will flow for how it is flowing, this will flow like that. On state will flow like that electrons. On next coming to off state, so same picture, that this one is there, no, switch will be there, no, the switch will be open condition now. So like that we have one power, we make it as a plus or a minus, will come this one pulse transformer, and one switch will be there. Next one diode, next one capacitor, next some load called L. So like that will be there. So this is a switch I'm using for AC and DC or AC power supply. The switch will be open. Now it's off state. Switch will be off state means the time how it is working means that the power supply will work. It will work for this one, the entire this line. This will work. This will be for off state. So this is how this is like that only working for this one playback topology. If you have any doubts or like that, please put your comments. I'll reply you next session. So if you have any doubts, further you can discuss. The next section will update you for Bangalore converter design, calculations and everything. So we are from DNCL Technologies. We are offering for so much services like hardware design services. Then we are offering for circuit design services, schematic design and design calculations, and firmware PCB layout service we offer. If you have anybody looking for our service, please contact us and DNCL Technologiesinfo at gmail.com, or please visit our website www.dncltech.com. Thanks for watching this video. If you have any doubts, please put your comments, and please subscribe our link, and please click on our bell button. Then only you get for our whatever videos we are uploading, you get notification immediately. So if you have any doubt, please let me know. So hi guys, so this is here I'm using for AC to DC converter, and same like flyback topology only. And here I'm using for a bridge rectifier, then I'm using for my inductor, then I'm using for this one, what I called pulse transformer, then a diode and capacitors. This for diode, this for capacitors, this for bridge rectifiers. So before I already uploaded a bridge rectifier how it is working. So see this section we understood more. And this is for anode, this is for cathode, this for anode, this for cathode, this for anode cathode, so this for anode cathode. So cathode is DC plus, and anode is minus for this one. So this you can take anyway, no problem. So next coming to this one, and using for inductor L. So this using for here EMI filter purpose we are using, and then we are using for fault transformer, this for switch, and next for diode. And here we will get waveform for waveform here on means like that will come, off means like that will be there, this again will will be there, right? So like that only is working for this one. So we'll get for here pulsated waveform means like that, pulsated waveform means this will be there, like that will be there. So I need the DC straight line, so we'll get for Python. So it will only allow for one direction positive cycle only, so that time will come only for straight line. Then capacitor using for this won't allow for the AC signal. This is for decoupling capacitors we are using. And then using for load, this for major circuit of this one, playback topology. So next we can discuss feedback circuits, and we can discuss clamp circuits. Next we can discuss for protection circuits. So this wise we working, and we'll go for next calculation wise also. So thanks for watching DNCL Technologies.